Hi, I'm John, and today I'll be going over the definition of a function and an example which corresponds with it. Definition of function. A function is a rule that takes certain values as inputs and assigns to each input exactly one output value. We say the output is a function of the input. Therefore, a variable y is a function of the variable x, provided that each value of x determines exactly one value of y. Let's move on and let's try this example here together. A national park contains foxes that prey on rabbits. The following table gives the population over a 12-month period where t equals 0 means January 1st, t equals 1 means February 1st, and so on. The first row in the table corresponds to the number of months, second row of the table corresponds to the number of rabbits, and the third row, the number of foxes. The problem asks us two questions. First one, is f a function of t? The second question, is t a function of f? Explain why or why not. The best way to solve this particular problem is to create a mapping of input and output values. Let's try to answer the first part of this question. Is f a function of t? Based on how this question is written, and if we compare this to the definition of a function, we can clearly see that t represents the input values. And now f represents the output values. Let's relist the number of months as our input values. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And let's also list the number of foxes without repetition. 50, 57, 75, 100, 125, 143, and 150. Now, based on how the table is constructed, we can now create our mapping. 0 goes to 150, 1 goes to 143, 2 goes to 125, 3 goes to 100, 4 goes to 75, 5 goes to 57, 6 goes to 50, 7 goes to 57, 8 goes to 75, 9 goes to 100, 10 goes to 125, 11 goes to 143. Based on the definition of a function, aka for every input, there must exist exactly one output. In this mapping, this is true, because for each input t, a unique output f is assigned to it. Let's try now to answer the second part of this question. Is t a function of f? If we compare the question with how the definition is written, f is now the input values and t is the output values. Let's construct a similar mapping as we did from the first part of this example. Let's list out the number of foxes as our input values without repetition. 50, 75, 57, 75, 100, 125, 143, 150. Let's list out the number of months without repetition. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Again, based on how the table is constructed, we can now draw our mapping. 150 goes to 0, 143 goes to 1, 125 goes to 2, 100 goes to 3, 75 goes to 4, 57 goes to 5, 50 goes to 6, 57 goes to 7, 75 goes to 8, 100 goes to 9, 125 goes to 10, 143 goes to 11. Keep in mind what the definition of a function says. For each input, there must be exactly one output. Based on this mapping, this is not true. because there exists at least one input with more than one output. Thank you for watching. Thank you for listening, and have a good day.